Okay, today we're going to cover section 4 in chapter 8, and it's on trig. I know you guys have all been real excited and anxiously awaiting this. I'm just sorry I couldn't be there to see the excitement on your faces. When we use the trig ratios, we only use it with the right triangles. Now when you get to Algebra 3 and trig, you will start learning how to apply the trig to other triangles besides right triangles, but we are only concerned with right triangles. And of course, in a right triangle we have the hypotenuse and the two legs. Now the hypotenuse will always be the hypotenuse. The legs, on the other hand, are going to be categorized into an opposite leg and an adjacent leg. And it depends on which angle you are using, whether it is an opposite leg or an adjacent leg. So the first one we'll look at is angle A. With angle A, the angle is up here. And so when you look at angle A, the leg that is opposite of angle A is side BC. So with angle A, the opposite leg is segment BC. And that is because it is across the triangle from the angle. The adjacent leg is going to be the leg that is attached to angle A. Because remember, we've talked about adjacent angles and things being adjacent, and it's the same thing here. So segment AC is going to be the adjacent leg. But when we change our point of view down to angle B instead, the hypotenuse is still the hypotenuse, but the opposite and adjacent legs now are different. This time, the opposite leg is, of course, the side that is across the triangle on the opposite side, and it is now AC. So the opposite leg is now AC. And the adjacent leg to angle B is the leg that is attached to angle B, and that is going to be side BC. Now, how are we going to use this stuff? Well, somebody long time ago decided to investigate right triangles and the relationship between the sides, depending on what size the angles were. And they started noticing that with right triangles, the sides ended up forming ratios. And they ended up calling those ratios the sine, the cosine, and the tangent. Or as a lot of people like to call it, sin, cos, and tan, because those are the buttons on the calculators. Now, for the sine, it is always going to be the opposite leg over the hypotenuse. The cosine is always going to be the adjacent leg over the hypotenuse. And then finally, the tangent is going to be the opposite over the adjacent. An easy way to remember this is SOHCAHTOA. I know it sounds like I'm talking in a foreign language, but I'm not really. I'm just using an acronym where it's just the first letters of the ratios. The sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Last thing we are going to do today is see how to set up the ratios when we have a right triangle. So, for the cosine of angle R, that means we are going from angle R's point of view. We look at our cosine ratio, and it is adjacent over hypotenuse. So the cosine of R is going to be the adjacent leg, And so when we look at our picture, we look and see which side is adjacent to R, and that is the 4. So it goes up on top. Which side is our hypotenuse? It's the 5. So the cosine of R is 4/5. Now we do the same thing with the sine. With the sine, it's the opposite leg over the hypotenuse. So now, going back to R, we ask ourselves, which leg is opposite angle R? Well, it's the 3. So the 3 goes on top, and the hypotenuse goes on the bottom. Tangent, right here, is opposite over adjacent. So from angle R, we do the opposite over the adjacent. Oops, and the line didn't draw. There we go. Now when we change our point of view to angle S, well, angle S is up here. Now, oops, cosine, let me zoom out here a little bit. Cosine is still going to be adjacent over hypotenuse, but since we're going from angle S, the adjacent leg changes. This time it's 3. Hypotenuse is 5. The sine is still opposite over hypotenuse, but since we're going from angle S, the opposite is 4, hypotenuse is 5. And the tangent of S is still opposite over adjacent, so the opposite over the adjacent, and this time is 4/3. And that is our trig ratios.